Okay, so we wrote a little program, and which one of you wants to walk us through how this program works?
Okay, I'll do it.
All right. So you can point to things on the screen.
So first, we just have our numbers that we're checking for the first half of the equation.
Okay.
So we start at 1, we go to 5, and then just keep adding. So then our number on the left side of our equation, the 3 plus 8n, that's we called x.
Yeah. So we should have called this n to be consistent, but we called it I, which is fine.
And then b is the square root of x. This is what we have to check up to for our squares.
Okay.
And then this is a flag that's going to come in later. So then we have a second loop that says that did check the squares. So we use j for j equals 1, j less than b, which is the square root of x. J adds by 2 because we only need to check the odd squares.
Okay, cool.
And then c is going to be what we check if we have a prime that works. So c is x minus j squared. So our left side of our equation minus the square divided by 2.
Okay.
And we want that to be prime.
All right.
So if it's prime, then we're going to print that our x equals our j squared plus 2 times our prime c.
Uh-huh.
And then this sets the flag equal to 1 to tell us that we have a solution.
Okay.
And then if we didn't go through this loop and the flag never got set to 1, and it's still 0, then we print that our number had no solutions.
Okay, nice. So here we just checked the first 4 cases, and which were coincidentally the ones we checked in the project before. So we found 11 is 1 squared plus 2 times 5. And then we found, 19 had 1 solution, 27 had 1 solution, but 35 had the 3 solutions that we found.
Yep.
Okay, so now maybe we can check a few higher cases. Maybe we can go up to, maybe we'll check the first 10 cases. So the next number that we haven't looked at was 43, and what did that equal?
3 squared plus 2 times 17.
And
Yep.
Yep.
It does.
Okay. Did we have any failures?
No,
No,
if we have no failures. So if we had a failure, then we would solve this unsolved problem.
Yeah, it would have been pretty surprising that this would have been unsolved for a couple hundred years, and
No,
like 83 didn't work.
Yeah. And this probably has been checked up to like the trillions.
Yeah,
Probably higher.
usually. Any surprises you see up on here so far?
No, not really. And 83 has 4. That's kind of interesting.
Yeah, 83 has a bunch of solutions. Okay. All right. Now, so if we wanted to check, say, like for the first 1,000, we can do it. But what's going to be the problem when I hit return and this runs?
It's gonna take a while.
Nah, it won't take that long. So it's only 1,000.
And we're gonna have a super long list, I guess.
Yeah, we're gonna have a super long list of everything where it told us it worked.
So maybe we just don't print where it works, and then we print only if it doesn't work.
Yeah. So if we're just interested for now for where something doesn't work.
just delete that line.
So I can just delete that out, edit, cut, and then run it.
So as long as we get nothing back, it'll be fine.
Yeah. And it ran real quickly, and so everything up to 1,000, the first 1,000 cases worked just fine.
No, it's not all that surprising.
Not all that surprising. If I put that back in,
We got just a long list of all the numbers.
yeah, and we can go look just for fun down at the bottom of that list. Oh, it's still running, sorry.
1139 has a lot.
Yeah, talk about that while this thing's finishing.
1, 5,
1, 2, 3, 4, 5, 6, 7, 8, 9.
9 solutions. Looks like they all have multiple solutions up this high.
Oh, okay. So now we're starting to see some interesting.
Yeah, it looks like the vast majority of them have a lot of solutions. I'm not. It does look like all of them seem to have more than one. I mean, that's not too surprising since the numbers are huge.
1763 has
Yeah,
a lot.
how many solutions does that
2,
have?
3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 solutions.
Wow. Sorry, I'm having a hard time
2043 is this one.
scrolling down
Lagging.
here.
I guess we have so many numbers that it's difficult to display them all.
Yeah, well, it must be still running, because it's giving me a hard time with scrolling down, which is a little annoying. All right, well, there I scrolled down to the 5,000s. Yeah, so what are some other conjectures that we could make? Or what are some other numbers that might be interesting to us if we wanted to modify this program a little bit instead of printing everything out?
We could print like numbers that had more than like 15 solutions. Or
Okay, nice. So we could look for numbers that have lots of solutions.
we could look for numbers that have only
one solution.
Only one solution, so sort of almost solutions to the problem. So yeah, so all of a sudden, now when we start looking at lots of solutions, now we can start seeing, hey, some numbers have tons of solutions. Maybe some numbers only have a small number. It's hard to see on our big list. Although look here, 5131 only had 2. That's pretty small.
Compared to 5123.
Yeah.
they got at least 15.
All right, now it's done running. So yeah, so there's actually a lot of fun things we could explore. Maybe we could see patterns in ones that only had one solution. Maybe.
We could make like a histogram if we wanted to of number of solutions.
Oh yeah, actually that would be really cool. We could keep track of the number of solutions. Why don't we do that actually? Because that's not going to take too long to modify, and then we'll run it and see what that looks like.
Okay.
Yeah, it's a great idea. Let's do that.